All right, so you're obviously here because you're keen to learn a lot and you want to learn it quickly and properly.
Indeed.
And that's what we try to do here. Today, we're going to take a really deep dive into the Gemini 9A mission. It wasn't just any old space flight. It was set against quite a dramatic backdrop, right from the start, actually, marked by tragedy and plagued by some really tricky technical challenges right the way through.
Yes, it's a mission that, even though it didn't meet all of its main objectives, it offers a really fascinating case study in what early spaceflight was actually like. We've got a lot to go through, detailing everything from the crew and the awful accident that meant they had to be replaced, to the problems with the target vehicles, the docking attempt, which, as you know, was problematic, shall we say, and finally, that really difficult spacewalk.
Exactly. So our mission today, if you like, is to sort through all this information and pick out the most important, or perhaps the most interesting, bits of the Gemini 9A story. What do you think?
I think that's a good plan. We'll try to give you a really solid understanding of what happened.
Right.
And why it matters in the wider story of space exploration.
Right. Let's get into it. So the Gemini 9 mission, originally they had Elliot M.C. Jr. as the command pilot, and Charles A. Bassett II as the pilot.
Yeah.
And they were both really looking forward to their first trip into space.
Yes, that's right. C was a civilian test pilot, one of the second group of NASA astronauts, and Bassett was an electrical engineer and test pilot from the third group, and this mission was going to be their first time in space.
But tragically, fate had other ideas.
It did.
On the 28th of February, 1966, just 4 months before their scheduled launch, both C and Bassett died in a plane crash.
Yes.
They were on their way in a T-38 jet trainer to St. Louis, going to inspect the Gemini 9 spacecraft they were meant to command.
And the conditions at Lambert Field that day were very poor. There was low visibility, and they were trying to make a visual approach and landing when the aircraft, piloted by C, hit one of the factory assembly buildings. It was a fatal accident for both of them.
Awful. A real blow for the mission. But of course, they had to adapt and make new plans, so the backup crew had to step up, which was Thomas P. Stafford as the command pilot and Eugene A. Cernan as the pilot.
Yes. And Stafford had already flown on Gemini 6A, so this was to be his second spaceflight. For Cernan, though, this was his first spaceflight as part of Gemini 9A.
Right.
This was actually the first time since 1962 with Mercury Atlas 7 that a backup crew had been promoted to prime crew.
Right.
Really unusual. Of course, that meant they needed a new backup crew. James A. Lovell Jr. and Edwin E. Buzz Aldrin Jr. stepped into that role. They were originally the backups for Gemini 10.
That's a lot of reshuffling.
It is. And actually that had a big impact, especially for Aldrin. The usual crew rotation was to be backup, then wait for a couple of missions, and then maybe get assigned as a prime crew. Because he became backup for Gemini 9, he ended up on the prime crew for Gemini 12.
Oh, right. And that was really important for his career, wasn't it?
It was.
Being the prime crew on 12 was what led to him being chosen for the Apollo 8 backup crew.
Yes.
And then, of course, he was the lunar module pilot on Apollo 11, which made him the second person to walk on the moon.
Imagine that.
What a twist. You know, and all because of this terrible accident and the crew changes that followed.
It really highlights how closely connected those early space programs were and how events that you couldn't predict could affect the crew assignments and even change the course of space history.
Yeah, right. So they sorted out the crew, even though it was a really sad situation.
Yes.
So the mission had to go on. The main objective, as you could probably guess, was to build on the success they'd had docking during Gemini 8. The plan was to dock with an Agena target vehicle, or ATV.
Yes, that's right. And this particular one was the Agena GATV 5004. It was pretty big, a mass of 3,252 kilograms. It launched on the 17th of May in 1966 from Launch Complex 14.
But then, well, I guess fate had other plans.
It did, rather.
Only 7 minutes into the flight, the Atlas launch vehicle malfunctioned.
Oh.
And the ATV didn't make it into orbit.
That was a big setback. So close to the planned Gemini 9 launch, NASA had to scrub the mission. Like what happened with Gemini 6, it was redesignated as Gemini 9A.
Right, so Plan A was a no-go. Luckily, they had a backup, the Augmented Target Docking Adapter, or ATDA.
Exactly. The ATDA number 02186 was a lighter alternative, weighing about 794 kilograms.
Right.
It was designed by McDonnell Aircraft Corporation, the same people who built the Gemini spacecraft.
Right.
The idea was to use the re-entry control section of a Gemini instead of the Agena rocket stage. All equipment that had been tested and was known to work. It was a plan they came up with after the initial Gemini 6 launch failed. It shows how much they thought ahead when they planned these missions.
And thankfully, the launch of the ATDA on the 1st of June, 1966, went off without a hitch. It made it into orbit. But wasn't there a sign of trouble?
Yes.
Some telemetry suggested there was a problem with the launch shroud.
There was. Even before Stafford and Cernan launched on the 3rd of June and met up with the ATDA, they knew something wasn't quite right with the protective cone-shaped nose shroud.
Right, and when they got close enough to see it, it was pretty alarming.
It was.
The crew confirmed that the shroud was still stuck to the ATDA. Stafford said it looked like an angry alligator with its two halves hanging open.
Now, this is interesting. The explosive bolts that were meant to separate the shroud, they had fired. But the problem was with the quick disconnect lanyards that were meant to unlock the electrical connectors to these bolts, they simply hadn't been connected properly. So the electrical wiring to the bolts was actually holding the two steel shroud retaining bands in place.
I see, so that's why it didn't fully eject.
Yes.
Stafford, being a test pilot, he even thought about using the Gemini spacecraft itself to try and pry open these jaws. But ground control, understandably, said no.
Yes.
They were worried it might damage the only way they had of getting back home.
Of course. And then there was Buzz Aldrin's suggestion, relayed from the ground. He thought Cernan could cut the wires during his planned EVA. However, ground control were really worried about that. Deke Slayton said they were just aghast at the idea. There were a lot of concerns about the unpredictable nature of what would happen when the shroud came loose, how the ATDA was rotating, and the risk to Cernan's spacesuit. They had actually done tests on the ground, and it turned out the ATDA had some pretty sharp edges.
Oh, right. It sounds pretty risky.
Yeah.
And what caused this problem with the lanyard in the first place? Seems like it was down to a last-minute change in the launch vehicle.
Exactly. The shroud was built by Douglas, and it was meant to fit onto NASA's Agena second stage. But the Air Force decided they wanted to launch it directly with an Atlas. So McDonnell personnel, they weren't familiar with this particular fairing.
Right.
And they ended up having to install it straight onto the Atlas. They even stopped the Douglas engineer, who usually looked after the process, from getting involved.
Right.
So they ended up following Lockheed procedures, referring to a blueprint that wasn't even relevant in this case. And the Douglas technician who knew how to deal with those dangling lanyards, he wasn't there.
Right.
The McDonnell crew, they didn't know what they were for, so they just taped them up underneath those small fairings that protect the explosive bolts. They did a demonstration after the launch that showed exactly how this mistake happened.
Right. So the end result was that the main mission objective, docking with a target vehicle, wasn't going to happen.
Such a shame after all that work. And did it raise any wider concern? I mean, about how reliable these complex systems were when they had to integrate parts from different manufacturers?
It did. Aside from the immediate docking failure, it highlighted potential weaknesses in how they oversaw things.
Right. And the importance of making sure that everyone involved understood every single component, no matter who made it. It showed the need for really careful attention to detail and having good communication between the different agencies and contractors. This failure definitely led to stricter rules for later missions.
Yeah, absolutely. So let's move on to the second main objective for Gemini 9A, which was Eugene Cernan's spacewalk, his EVA.
Yes.
It was quite ambitious, mainly because they wanted to test the USAF Astronaut Maneuvering Unit, or AMU.
That's right. The AMU was a self-contained rocket pack. It was designed to let an astronaut fly around on their own without being connected to the spacecraft's life support. It had its own propulsion, stabilization, oxygen supply, and telemetry so they could track how the unit and the astronaut were doing.
Right. Cernan's EVA began on day 3 of the mission. But it seems it ran into problems almost immediately, didn't it?
It did. As soon as Cernan pressurized his suit to 3.5 pounds per square inch, he found it was incredibly stiff. He said it was like having all the flexibility of a rusty suit of armor. Just getting out of the spacecraft was a real struggle. Once he was outside, he started tumbling around uncontrollably. The umbilical cord thrashing about didn't help.
Not the best start to a spacewalk. He then had to get to the back of the spacecraft to even reach this AMU.
Yes.
Must have been quite a challenge.
It was a slow and difficult process. The AMU used hydrogen peroxide as propellant, which produced very hot exhaust gases. So to protect Cernan from the heat, they'd modified his suit with trousers made from this woven nickel alloy called Chromel-R.
Right.
It's a material they later used in the gloves and moon boots for the Apollo spacesuits.
Interesting. So some forward-thinking technology there, even in the midst of all these difficulties. But getting to the AMU must have taken it out of him.
It certainly did. As he disconnected from the Gemini umbilical and tried to connect to the AMU, his heart rate went up to about 155 beats per minute. His suit was so rigid, and there weren't any proper handholds or footholds. Every task was so difficult and took so long. Even just turning a valve was a huge effort. This experience was key. It showed them how even small increases in pressure could make astronauts completely ineffective outside the spacecraft. This is what led to the big changes in suit design for Apollo, where they focused on mobility and keeping the temperature right.
Right.
Which were vital for working on the moon.
Yeah, absolutely. And things got worse, didn't they?
They did.
He was getting more and more exhausted, and his pulse shot up to a worrying 180 BPM.
The flight surgeon on the ground was quite worried that Cernan was going to pass out.
Oh, right.
On top of that, his visor was fogging up because of all the sweat.
Right.
He was trying to rub his nose on it to clear a little bit so he could see.
Oh, wow, that's not good. So he finally manages to connect to the AMU. Mission Control were then in a bit of a debate about whether to go ahead with the test flight. Given how bad Cernan's condition was. What do you think about that?
Well, Cernan had already decided it was too risky to try and use the AMU like this. His vision was really bad. He couldn't move properly.
Right.
And he would have had to disconnect from the Gemini umbilical, just relying on a longer, thinner tether.
Right.
And then he'd have to remove the AMU with one hand while holding on to the spacecraft with the other.
Sounds like a disaster waiting to happen.
Indeed.
So even though Cernan wanted to keep going, Stafford made the sensible decision to cancel the AMU test and tell him to come back inside.
Absolutely.
It really highlights the life-or-death situations they were dealing with, the tough decisions they had to make. But even getting back to the cockpit was another struggle, wasn't it?
It was. Stafford had to hold on to Cernan's legs and help him back inside. And then when Cernan was trying to remove a mirror from the side of the spacecraft, the cooling system in his suit overheated. His faceplate fogged up completely. He couldn't see anything.
You can only imagine the stress. They must have been panicking. And then getting back into his seat was really painful.
It was. His suit was still fully pressurized. He had to squeeze himself down into the seat to close the hatch.
Oh, wow.
It was a very painful process. But they did manage to close the hatch and repressurize the cabin. After a really difficult 128 minutes outside, Cernan was back in.
It really shows the limitations of those early spacesuits. The fact that the Gemini suit was only air-cooled meant that if you exerted yourself, you'd overheat and the visor would fog up.
Yes.
And they couldn't do anything about it.
For the later Gemini EVAs, they reduced the workload, and for the Apollo missions, they switched to water-cooled suits.
Right.
They had this undergarment with a network of tubes that circulated water near the skin, a much better way of controlling the temperature.
Yeah, and apparently the Gemini 9A suit didn't even have temperature probes. Because they'd taken them out to make room for more life support system equipment, the ELSS. So they didn't know exactly how hot it was getting inside the suit.
Yes.
Cernan could certainly feel it, though.
They found a tear in the insulation when they examined the suit afterwards, which might have been part of the reason it got so hot. In a later interview, Stafford said that he was really worried Cernan wouldn't make it back into the capsule.
Right.
And he was even thinking about what might happen if they tried to re-enter with Cernan still tethered outside.
It's quite a sobering thought.
It is.
So it's no surprise that the AMU was never used on any other Gemini missions. They didn't think it was necessary for Apollo. In fact, they didn't test any maneuvering units in space again until 1984.
That's right. And the problems with the EVA meant they couldn't do some of the other things they had planned. An experiment that was meant to take pictures of the zodiacal light during an EVA had to be done inside the spacecraft. And the experiment to test how well they could control the AMU, obviously they couldn't do that.
Right.
Even a UHF-VHF antenna on the spacecraft got damaged when Cernan was struggling outside.
And physically, the toll on Cernan must have been huge.
It was.
He lost quite a bit of weight.
He did.
Mainly during that difficult spacewalk.
Yes. He lost up to 13 pounds in total, with 10.5 of those lost during the EVA itself. Stafford said afterwards that he found quite a lot of water in each of Cernan's boots, maybe 1 pound to 1.5 pounds.
Gosh.
It really shows the strain he was under and the effects it had on him.
Yeah. It's clear that although the spacewalk didn't achieve its main aim, it taught them a lot about how difficult it was to work in space.
Absolutely. The problems they encountered led to a mission review committee being set up after Gemini 9A to make sure that future missions had more realistic goals and that they would definitely benefit the Apollo program.
Right. So after all these issues, how did the mission end?
Well, thankfully, that part went fairly smoothly.
Right.
On their 45th orbit, they fired the retro rockets, and the reentry was spot on. They splashed down on June the 6th, 1966, very close to their planned landing site, only 700 meters away, near the recovery ship, the USS Wasp.
Good. Bit of precision after all those problems.
Yeah.
But it's fair to say that they didn't manage to dock, and the EVA and AMU tests were cut short. What about the scientific experiments? How did they go?
A real mixed bag. They got some usable data from some of the photography experiments.
Right.
But some of the other ones, like retrieving the micrometeorite collector and the experiment to look at AMU control, they couldn't do those because of the docking failure and the problems during the EVA.
Right.
And like we said, an antenna experiment was damaged during Cernan's spacewalk.
So a mission with its fair share of setbacks.
Yeah.
But they must have learned some valuable lessons, right?
Absolutely. The mission showed them how difficult it was to do EVAs in those conditions,
Right.
and how important it was to test everything properly and to have good communication between all the agencies involved, especially after the ATDA shroud failure.
And I think it's worth mentioning the scale of the support they had for these early space missions. The Department of Defense played a huge part.
They did.
Thousands of people, aircraft, and ships were involved in supporting Gemini 9A.
Over 11,000 personnel, 92 aircraft, and 15 ships, to be precise. It shows how much effort went into even these early space flights.
And interestingly, even the mission patch tells a story. It shows the Gemini spacecraft docked with the Agena. And a spacewalking astronaut, even though they used the ATDA and didn't actually dock.
They didn't change the design even though the mission changed. It kind of reminds us of what they had hoped to achieve and how those plans had to be altered.
Right. So to sum up this eventful deep dive into Gemini 9A, it was a mission defined by things they hadn't planned for. From the tragic loss of the original crew to all the technical issues with the target vehicles and the challenges they faced during that very difficult spacewalk.
Exactly. And even though they didn't achieve those main objectives, docking and the AMU test, Gemini 9A wasn't a failure. They learned so much.
Right.
It provided valuable insights into spaceflight, especially about how demanding EVAs are and how important it is to test everything thoroughly and make sure all the teams are communicating well.
So a final thought for you to consider. Given all the obstacles they faced during Gemini 9A, which factor do you think had the biggest impact? Was it the human tragedy at the start? Or the technical problems with the target vehicles? Or the limitations of the spacesuit technology? It certainly makes you think about how resilient they were and all the important lessons they learned as they pushed the boundaries of what humans could achieve.